A RAG that works in a demo can still fail in production. To trust it, answer two questions. Is it good, and is it fast and cheap? The first is evaluation, the second performance. They share one rule: you can't optimize what you can't measure. So measure first. And here's the key to measuring quality. A RAG pipeline has two stages: retrieval and generation. So a bad answer has two suspects: the retriever that fetched wrong context, or the generator that had good context but answered wrong. Evaluation pins the blame on the right one. Start with the retriever. Did we actually fetch the answer-bearing context and rank it near the top? The classic metrics come from information retrieval. Precision at K. Of the chunks returned, how many are relevant? Recall at K. Of all relevant chunks, how many did we find? Position matters too. Mean reciprocal rank rewards the first relevant chunk being high. NDCG rewards ranking all relevant ones above the noise. Frameworks like RAGAs wrap these into context precision. Is the context on target? And context recall. Did we get everything the answer needs? Get this wrong, and nothing downstream can save you. Now the generator. Even with perfect context, the answer can be wrong, off-topic, or unsupported. Think of the RAG triad: three relationships. Context relevance: are the chunks relevant to the question? Answer relevance: does the answer address it? Groundedness: is the answer supported by the context? How do you score these at scale, without a human? An LLM as a judge. A strong model grades each response against a rubric. No gold answer needed. That's how RAGAs works. Notice how the triad splits the blame. Context relevance tests your retriever, answer relevance tests your generator, and groundedness sits in between, which leads straight to hallucination. Hallucination is the groundedness failure. The model states something the retrieved context never supports. To catch it, use faithfulness scoring. Break the answer into individual claims, then check each one against the context. The score is the fraction of claims supported. 2 of 3 supported, 1 invented, means 67% faithfulness, a hallucination you can flag. Preventing it is a stack of defenses. Ground the prompt. Answer only from context, else say, "I don't know." Demand citations, and improve retrieval so there's less need to guess. And add a verification gate that regenerates or abstains when an answer isn't grounded. Now the other half, performance. Start with latency. Where does the time actually go? Embedding the query is tiny. Vector search is fast if approximate. A re-ranker scoring candidates is more expensive, and the LLM generation usually dominates the whole budget. Each stage has levers: approximate search instead of brute force, a lighter or skipped re-ranker, streaming tokens so the answer appears immediately, and a shorter context to speed generation. But 2 levers are structural enough to deserve their own treatment: shrinking the vectors and caching the work. Let's take both. An embedding is usually a list of 32-bit floats. A 1,000-dimension vector is 4 kilobytes, and millions of them are enormous. The trick is brutally simple. Replace each float with a single bit, 1 if positive, 0 if not. That's a 32 times memory reduction instantly. Distance gets faster too. Comparing 2-bit vectors is just a Hamming distance, an XOR and a bit count, a couple of CPU cycles, roughly 25 times faster. The catch is accuracy. The fix is rescoring. Pull a larger shortlist with the binary index, then re-rank it with the original float 32 vectors, recovering most of the accuracy, keeping the speed. The last lever is caching. Never do the same work twice. The simplest layers cache exact repeats, the query's embedding, its retrieved chunks, even the final answer. The powerful one is the semantic cache. It keys answers by the query's embedding. When a new question is close enough in meaning, it returns the cached answer instantly. No retrieval, no generation. So 2 paraphrases hit the same cache entry. The trade-offs: cached answers go stale when your knowledge base updates, so set an expiry, and too loose a threshold returns the wrong answer. And that's the thread tying this course together. Every optimization must be rechecked against your eval suite. Measure, optimize, measure again. Because you can only optimize what you can measure.